All right, this is Mr. Gillum, and today we're going to look into some properties so we can really understand how these expressions work and how we can evaluate these expressions and why we can do what we can do. And so the first property is the distributive property. Now this is, I know, is review because we practiced this one several times. And the distributive property works both ways. You may multiply a number or a term in front of the parentheses by everything inside the parentheses, like this, and distribute 4x plus 2, or you can factor is what we call it. Factor. It's a type of the use of distributing property. And that's when we have something like 4x plus 2, and we notice that 4 and 2 have a greatest common factor of 2. And we move backwards. Okay, and we pull out that greatest common factor. And so we can either multiply or we can divide the greatest common factor to the outside of the parentheses, okay, or factor. And so that's the distributive property. And so hopefully we become more familiar with that, but we do need to know that property by name when I say the distributive property. The next few properties are probably review. Actually, they should probably be new. The commutative property of addition and the commutative property of multiplication say that if you are adding or you are multiplying, it does not matter which order you multiply or add in, it will still have the same outcome. So, for instance, we know for addition that 3 plus 2 equals 5, and we know 5 equals 2 plus 3. So we also know that 3 plus 2 must equal 2 plus 3. Okay, when we change the order of 3 plus 2 to 2 plus 3, that's called the commutative property of addition. All right, 3 plus 2 is the same as 2 plus 3. Or we could think of it like this. 4 plus 1 plus 2 is the same as 2 plus 4 plus 1. It basically says no matter what order you're adding, as long as you're adding, you can change the order around, and then you can add the terms together, and you'll have the same outcome. So 4 plus 1 plus 2 is 7, and 2 plus 4 plus 1 is 7. So you can just change the order. And so what I want you to write down is order. The commutative property has to do with order. Okay, but it only works for addition and multiplication. Okay, so for instance, 2 times 3 is 6, and I know 6 is also equal to 3 times 2. Well, if 6 is 2 times 3 and it's equal to 3 times 2, then I know that 2 times 3 must equal 3 times 2. And so that's how the commutative property of multiplication works. It doesn't matter what order you multiply things in, but you'll have the same product. And it works with more than one as well. 4 times 2 times 1 is the same as 2 times 4 times 1. Okay, I can switch that order around and I'll still have the same product. All right. So the commutative property has to do with order. So that's a good word to remember is order there. Commutative property has to do with order. There are some operations like subtraction and division that the commutative property does not work for. For instance, if I had 2 minus 1, it is not the same as 1 minus 2. In fact, if you think about it, 2 minus 1 would be 1, and then if you're at 1 and you count backwards, it'd be 1 down to 0 down to negative 1. And negative 1 is not the same as 1, and so with subtraction, it does not work for the commutative property. Same way with division. I can do 4 divided by 2 pretty easily. I know that that's 2, but I know that 2 divided by 4 is not the same. It'd be 1/2, and 2 and 1/2 are not equal. So the commutative property also does not work with division. So subtraction and division are outlawed for the commutative property. You have to do those in the order that they're written. However, addition and multiplication, you can flip-flop the order on those. The identity property is one of my favorite properties because what happens is the term keeps its identity. And there's two ways to describe that, through addition and through multiplication. Now you probably knew these facts before, but if I have any number and I add 0 to it, it'll stay the same. Or the other way around, if I have 0 and I add any number to it, it'll be that number. And that's what the addition property says. It says if I have 2 plus 0, it's still equal to 2. It keeps its identity. Or if I have 5 plus 0, it's still equal to 5. Or if I have 3x squared plus 0, that is still equal to 3x squared. Okay, it works with variables, it works with any term. Anything plus nothing is still itself, and it keeps its identity. It doesn't change, okay? Identity. So for addition, it's adding 0. For multiplication, it's multiplying by 1. Whenever I multiply any number by 1, I know that number stays the same. So for instance, 2 times 1 is still 2. 3 times 1 is still 3. It's keeping its identity. It's not changing. And it works the same for variables. Anything times 1 equals itself. That term stays the same. And that's why when we have a variable, a naked variable, you don't see a number in front of the x, but if you need a coefficient, you assume that it's 1, because 1 times x is still x. Because the identity property of multiplication. So that's why that 1's there in front of it. We don't ever write that 1 because we know that the identity property says that we can multiply it by 1 and it's not going to change. So that's why that we assume that there's a 1 in front of the x here. If there's no coefficient, we always know it's a 1 because 1 times anything is still itself. So the identity properties, adding 0 to something or multiplying it by 1 will not change its value. And then finally, the associative property, and this might be my least favorite property of all. This one has to do with parentheses. So I'm going to write these parentheses out here. I want you to do the same thing. The associative property is associated with parentheses. And again, like the commutative property, this just works for addition or multiplication because those operations can be done in any order. However, the associative property has to do with moving the parentheses. So if I had an expression like 2 plus 3 plus 4, and it was grouped with the 2 and the 3 together, I could also group it differently because I have all addition. And instead of grouping it with just the 2 plus 3, I could group it separately. I could move the parentheses over 1 to 3 plus 4 like this. And so as you can see, I just moved these parentheses around different terms in my expression. And so the associative property basically says if you see all addition, you may move the parentheses and you may do the parts that you like first. And now we haven't learned about inverses yet, but this is especially helpful when we are adding negative numbers. Because if I had, I guess I should just explain it. If I had 2 plus 3 plus negative 2, it's like this would be really, really useful to use the associative property and the commutative property together. In fact, change this. I think we're just going to try to keep it to the associative property. Let's do 3 plus negative 2 plus 2. Okay. You know how there's always that one person that has like an advantage over everyone. You're like, man, I can't believe they did that fast. How did they know that? It's because that person uses strategy. And the associative property is one of those properties that is used for people that like strategy and like to do things quickly and know the tricks and get good at things very fast. Because when we start using negative numbers, you'll know that you'll learn that opposites, when added together, add up to 0. So instead of adding 3 plus negative 2 and then adding 2, a strategy would be to try to cancel things out. And this works even better with long problems. So it could be negative 3 plus negative 2 plus 2. Instead of adding these middle ones together first, what I would do is I would group the opposites together instead. And when you learn about this later, you'll know that, oh, well, that's 0 and that's 0, so my solution is 0. And it makes it way smaller if you notice that you can group certain things that go together better. And it works really well with multiplication. In fact, much better with multiplication. If I had 2 times 3 times 4, and the parentheses started around the first 2 terms, I could also move those to the second 2 terms and rewrite the problem like this. Now, it might seem silly because we know that any order that you multiply in will have the same outcome. However, it's actually very useful for fractions. Again, with the inverse properties, I know that 1/2, let's do 3 times 1/2 times 2. I'm going to group it like this. Now, 3 times 1/2 is going to be some sort of fraction. I don't see anything to reduce, reduce, cross reduce, cross reduce. But since I know the commutative property, and I also know that I can move those parentheses with the associative property, instead of finishing this problem or simplifying this problem the way it is, I would prefer to simplify it like this. Because when I look at it now, oh, well, taking 3 times 1/2 is kind of difficult, but taking 1/2 times 2 is really easy because I can just cross cancel out, or cross reduce is what I should say. I can cross reduce the fractions. And now all I have is 3 times 1. And so again, the associative property is for those people that are really good problem solvers because they know the tricks. And the trick to a lot of the problems that we do as they get more and more complicated is to look for opposites or look for inverses. And the associative property allows us to group things differently so that we can solve problems more quickly. All right, so those are the properties I want to talk about today. We had the distributive property, the commutative property, the associative property, and the identity property. All right, and that's it for today.